The quotient rule is a useful rule in differentiation to use when you've got one function divided by another function. For instance, in this case I've got the function 5x on the top and I've got it divided by another function 6x squared plus 2x on the bottom. Now what you can do is call each bit of the fraction by a variable name. So I'm going to call the top u, so u is going to represent 5x, and the bottom is going to be called v. Now what we're trying to find out, if we're differentiating this, is dy dx. Now the rule, or quotient rule, which we're doing it here, is that the differentiation of y you can get by going u dash v minus uv dash on v squared. So u dash is the derivative of u with respect to x, and v dash is the derivative of v with respect to x. So first off, let's find out what u dash equals. Well, we know that u equals 5x. So the derivative of this with respect to x is just going to equal 5. So that's u dash. What about v dash? We don't know what v dash equals yet, but we do know that v equals the bottom part of our fraction, 6x squared plus 2x. So the derivative of a v with respect to x is going to be, you take the 2 out the front, so 2 times 6 is 12, x, the power goes from 2 to 1, which is just x, plus 2. So now we can go back to our original quotient rule, which is dy dx equals u dash v minus u v dash on v squared. So we know u, we know v, and now we know u dash and we know v dash. So u dash is just 5, v is 6x squared plus 2x. Now remember, it's a minus here, so minus u is 5x, and v dash is 12x plus 2. Make sure you put this in brackets because you're multiplying the 12x and the 2 by 5x. Now we get to do the bottom of it, which is v squared. So we know that v equals 6x squared plus 2x, and where it's v squared, so we have to make this all squared. So now our job is just to simplify this as much as possible, and we have to put a little bit of work into this to get this into a much simpler form. So first up, let's multiply out the top of the fraction. So 5 times 6x squared is going to be 30x squared. 5 times 2x is going to be 10x. Then we've got a negative 5x minus times 12x, which is negative 60x squared, and a negative 5x times 2, which is negative 10x. Don't forget about the bottom part of the fraction. Now what I'm going to do here is actually, instead of writing the squared sign, I'm going to write out the brackets twice. So 6x squared plus 2x, and because it's squared, it's multiplied by itself again, so 6x squared plus 2x. Okay, so we're getting somewhere. Now first of all, the positive 10x and the negative 10x cancel out on the top. So on the top, we're just left with negative 30x squared. Now what I'm going to do on the bottom is, out of each bracket, I'm going to take an x, a factor of x. So I'm going to divide the bracket, what's inside the bracket, by x and put an x out the front. So the 6x squared becomes 6x, and the 2x just becomes 2. So all I've done is factorized x out of the brackets. And I'm going to do this for the second bracket, exactly the same process, 6x plus 2. Now the reason I'm doing this is I'm now going to be able to cancel out some of the x's on the top with some of the x's on the bottom. So if I rewrite, I get negative 30 x squared. Now on the bottom, I'm going to group together the factors, the x factors. So out the front, I'm going to be write x squared, and then 6x plus 2 times 6x plus 2. So I've just changed the order. It's exactly the same thing. But now I've got an x squared on the top, which I can cancel out with the x squared on the bottom. So what I'm left with is just negative 30 on the top, and I'm going to rewrite it in squared form. So 6x plus 2, because there's two of them multiplied by each other, it's 6x plus 2 all squared. And that's your derivative.